So if you're working with data in Python, you already know NumPy is an absolute beast. But, basic slicing, it can feel a little restrictive sometimes, especially when you need to grab very specific scattered data points. Well, today, we're unlocking 3 of NumPy's indexing superpowers. These are techniques that go way beyond a simple slice, letting you select, filter, and basically reshape your data with some incredible precision.
All right, let's just jump right in and see what we're talking about. Over on the left, that's familiar territory, right? A standard slice, 2-5, it's linear. It grabs a continuous chunk of data, just like a plain old Python list. But now, look at the right. That's the NumPy way. We're not just taking a single piece here, oh no. We're giving it a set of very specific coordinates to handpick individual elements from all over the array. It's a whole different ballgame, and it's so much more powerful.
So first up is integer array indexing. I kind of like to call this one the puppeteer. Think about it. Instead of just, slicing off a piece of the whole, you are pulling on specific individual strings. You get to create a completely new shape, a brand new array built from exactly the elements you want, no matter where they were in the original.
Okay, so here's the deal. We pass in arrays of integers, and those integers act as the coordinates for the elements we want to grab. But here's the real magic, the part you have to remember. The shape of your final array, it has nothing to do with the source array's shape. It is determined entirely by the shape of your index arrays. That is the key to this whole thing. Let's see it in action.
Here's our stage. We'll call this array A. It's a simple 3x4 array, filled with the numbers 0 through 11. Just kind of lock this picture in your mind because we're about to pull some very specific values right out of it.
And here, this is where the magic happens. These are our puppeteer strings. We've got 2 index arrays here. Array I has the row coordinates we want, and array J has the column coordinates. And you'll notice, this is super important, they both have the exact same shape. They're both 2x2.
So what NumPy does is pretty clever. It pairs up the elements from these 2 arrays, one by one. The first row index, 0, pairs with the first column index, 2, to give us the coordinate 0, 2. The next pair is 1, 1, then 1, 3, and finally 2, 3. These 4 pairs are the exact locations of the elements we're going to pull from our original array.
And bam! Look at that. NumPy goes to our source array A, finds the element at 0, 2, that's the number 2, then it finds the element at 1, 1, which is 5, then 1, 3 gives us 7, and 2, 3 is 11. And it puts them all together into a brand new array that, you guessed it, has the exact same 2x2 shape as our index arrays. You have total control.
All right, that was cool, right? Let's move on to our next power-up, Boolean masking. Now, if integer indexing was the puppeteer for picking things out, think of this technique as the sieve. You basically create a filter based on some kind of logical condition. You pour your data through it, and you only keep the stuff that matches.
It's actually a super intuitive 3-step process. You start with your data, you define a condition, something like find all the values greater than 4, and then you use that condition to literally select the data. Let's walk through.
So we're going to start with that same 3x4 array, A. But this time, our goal is totally different. We don't want specific coordinates. We want to filter the whole thing. And our condition is going to be simple. Let's find and pull out only the numbers in this array that are greater than 4.
And this is the beauty of it. The condition itself is so clean and readable. You just write A greater than 4. That's it. NumPy completely understands this and does an element-by-element comparison across the entire array, getting our sieve ready.
So when you run that, what you get back is this. It's a brand new array. Same shape as the original, but it's filled with Boolean values, true or false. We call this a mask, and as you can see, it's true wherever our condition was met, where the number in A was bigger than 4, and it's false everywhere else. This is our filter, perfectly customized to our data.
Okay, so we have our mask. Now for the payoff. We take this Boolean array, our mask, and we use it to index our original array, A. And just like that, NumPy pulls out only the values where the mask was true, giving us 5, 6, 7, all the way to 11. Now, one really important thing to notice here, the result is always a one-dimensional, flattened array. It just contains all the values that made it through our sieve.
All right, last one, and this is a total pro tip. Seriously, this is the ellipsis, and it is going to be your new best friend when you start working with high-dimensional data. Things like images, video, or complex scientific data sets. It is a shortcut that's going to save you so much typing and just make your code so much cleaner.
Come on, you've been there, right? Does this look familiar? You're trying to slice some crazy 4 or 5-dimensional array, and you find yourself just typing colon, comma, colon, just to say and all the rest of the axes. Well, there is a much, much better way.
Meet the ellipsis. It's just 3 little dots. So on the left, that's the old way. For a 5-dimensional array, maybe we want index 1 from the first axis and index 2 from the second. Then we need 3 colons to grab everything else, but look at the right. We do the exact same thing with dot dot. The ellipsis automatically expands to as many colons as it needs to. The result is identical, but the code is just so much cleaner to read.
And that's it. That's the ellipsis. We have covered a ton of ground here. So let's do a really quick recap of this new indexing toolkit just to make sure these concepts are locked in.
So, let's put it all together. What's in our new toolkit? We have integer array indexing, the puppeteer, which is perfect for when you need to handpick specific non-adjacent elements and build a whole new array. Then there's Boolean masking, the sieve, your absolute go-to for filtering data based on any condition you can dream up. And finally, the ellipsis, the shortcut for keeping your code clean and readable, especially with that complex high-dimensional data.
You know, learning this stuff, it really changes the game. It fundamentally changes how you approach data problems. You're not just slicing off generic chunks anymore. You're surgically selecting, you're filtering, and you're shaping your data with real purpose. These are really tools for thinking. So the only question left is, with these new powers in your toolkit, what complex data wrangling challenge are you going to solve first?